bit. We're going to be talking mostly about risk-based authentication, but I wanted to bring that in by showing a lot of the exciting new things that we're doing at Cisco around Zero Trust and really roll that in on how that combines. So we're going to start out taking a look at the web SSO piece, and what we're going to do is look at biometric authentication. I'll actually show a demonstration of what that looks like as we cross those various different technologies. Authenticate once and done with single sign-on. That's something that's pretty much a must in the industry today. And then we're going to look at how we view Zero Trust in combination with risk-based authentication, which is definitely not just assessing the user, but also assessing the device as they're doing authentication. So I'll be bouncing back and forth a little bit from the slides to a demo. And the first one I have up for you is to go over kind of the full gambit of Zero Trust with authentication stack here. And so we've got Lee here. Lee's our persona, and Lee's basically just going about the day-to-day activities that they do. They're going to start out here by accessing their file share. So they might have like a map drive or something like that, and they go to access that. Now they're actually getting an interactive authentication to log into the file share. So this is no longer like, typical SMB, like username, password stuff. They're going through the full gambit of biometric authentication. So you actually see Windows Hello prompted here during this authentication. Now, because we have single sign-on, we're not going to prompt the end user to authenticate every single time they want to access any type of resource. So we prompted the user that, hey, you're done authenticating, but we're not going to stop assessing the trust. So here we've actually accessed a file now that we've gotten through authentication, and we're going to move over to authenticating to a different spot. So this could be something like web, it could be something like another physical resource that they're trying to get into. In this particular case, this is actually the single sign-on portal for the organization. So again, evaluation of trust is happening there real quickly. Now the device is all green, which is why you're not getting stopped. So there's very little interaction for disruption for the end user here, right? So again, no real authentication for them, but just to let them know they're clear, they can go through, they access, for instance, Meraki dashboard that's attached via SAML to the single sign-on technologies, and they're in. So now let's take a look at remote desktop. So I'm going to go through my remote desktop, and then I'm also going to get a very similar experience. So it's kind of a different shift, right? We're used to, pretty basic authentication with this. Now we're shifting this over to doing a full authentication through the web browser, where that is, again, interactive. So our device, again, healthy, still green. We're going to go right through, very little disruption for the end user. Now the end user logs into the system. They're good to go, full access to everything.
So far, passwordless complete.
Passwordless complete. So these are layered all by DUO technologies underneath the hood, running all the authentication and also the application delivery stack. So you've actually got RDP is brokered by DUO Network Gateway, if anyone's familiar with the DUO technology. Now Lee's actually going to connect to the VPN. Beautiful piece that I love here. Thank you, AnyConnect guys, which is external access or external authentication through the browser. So we're actually going to stop here real quick before we do that. This is just showing that the full Zero Trust stack is in play, because AnyConnect is actually brokering security connections. So you got secure internet gateway here as well. So Lee actually goes to access the VPN now, and this is really different because we used to see an embedded browser here now. Now we see the full browser tab, and again, our passwordless authentication goes through. So device hygiene and posture, again, is checked here. We're all green, we're good. Now we'll actually shift a little bit, and we'll take a look at what happens when we want to do something silly as an end user, like mess with the security on the device. So device hygiene has actually been running in the back, and the DUO health application has been collecting telemetry on this device. So if Lee, our persona here, goes and does naughty things like, let's say I'm going to hop into Windows settings and go disable the Windows firewall.
Naughty Lee.
Yeah, naughty Lee. So we'll take just a second to spin through this, and then the device health app is actually going to be running in the background, detecting this information and then feeding that info now to the browser during its authentication path. So we'll take Lee, going to go access that same system that she accessed before, open the device health app. It's actually checking there, and this self-service is coming into play here too. So we're not telling Lee, yo, you can't authenticate, Lee. We're just saying, this is our posture, and this is what the company has decided is secure. Go turn your firewall back on, and it guides Lee through that process. So now if Lee just refreshes the browser, Lee's able to actually log in now because the security and hygiene are passed, and then access again to those resources. So that's fully end-to-end how you see all the technologies flow, regardless of what I'm accessing, TCP applications, web applications, whatever those are, I'm actually presented with the same user experience as an end user, but the company actually gets to establish zero trust throughout all those paths.
What you mentioned Duo Health app, does that mean there's a client on the device?
It does, yeah. So Duo, actually, there's two clients there that you really saw from Cisco. You saw Cisco AnyConnect to establish the VPN and Cisco Device Health application. Now, goal down the road is to actually create a unified package, so you actually would have one. Now, the idea behind this application is that we deployed this as an application that can sit in line during authentication. It's very lightweight, and in fact, it can't make alterations to the machine. It can only suggest. And that's for contractor use cases and BYOD use cases where you don't have control to load AnyConnect. So we needed a kind of separate module there that was acceptable to do those kind of use cases.
So one of the tricks though is that if you get past the initial Duo authentication, you've essentially got the master key to the rest of the machine, right? So even though it's checking, if I'm able to forge in some way, grab your 6-digit passcode or whatever through Duo, once I get in, I'm into everything, absolutely everything.
Yeah, through single sign-on. However, keep a pin in that because we're going to address that problem just a little bit. And in fact, this is kind of a foray into that, right? So risk-based authentication is what we view as what the user needs during the start of authentication flow. And that's like no longer is it good enough to just check the user and do that. We've got multi-factor authentication, which is, dual push technology is the most common form. We've moved to other mechanisms like, U2F or WebAuthn or other things that make that easier. But, a lot of companies haven't adopted those, so there's certain technologies that don't work with WebAuthn. And so what we decided was, hey, we need to now do things where it makes sense to evaluate the trust of the user as well. And then maybe we don't actually do multi-factor authentication every single time. Or maybe we do multi-factor authentication. And in fact, if it's very low trust, we want to do a lot more to verify who the user is. So that's how we begin into this. We'll get into session trust analysis that covers the latter use case that you mentioned just a little bit. But to point out, really good benefits of risk-based authentication is compliance. We see that quite a bit where there's various different compliance requests, and you're able to satisfy those by doing things like reducing auth prompts when there's a high level of trust, but also adding additional authentication friction when you need to. And if y'all have been around any kind of Cisco or Duo technology, that we tout our ease of use. That's the number one pillar to Duo security. Well, if you can do something like use machine learning and intelligence to actually prompt users when it's necessary and expedite them when it's not, now you actually can add friction because it's not friction all the time. It's friction for bad actors, or it's friction for somebody who's maybe unknown yet, right? So that's exactly what we're going to do is increase that security in high risk scenarios.
So when you're doing some of that analysis, are you looking at it basically like on a per connection basis? If you're connecting to an ERP application, that's a connection, or are you almost looking at it like hey, you're going in and pulling this report, whoop-de-dee. Now you're going in and you're trying to access confidential information. Are you able to go beyond just the destination IP? Are you looking at more than that?
We are, yeah. And so it really depends on where you're executing these controls in an environment. Now, what we believe is it's basically a system of always verify whenever you can. And we start really with just the authentication piece. That's going to be the entry point into systems, right? As soon as I access a system, you saw that single sign-on panel there with all the different apps. Each time I go into one of those, and we execute that here today, as Cisco uses this same zero trust technology. And as employees, if we want to move from the company portal to our CRM system, we're verified every single time that we go through that. And then we are using a number of risk indicators. We'll actually get into the risk indicators and talk about like what we use to try to detect those things. And in fact, perfect setup. We actually found that the industry likes to do certain things that are pretty standard. So IP-based, that's very standard. Almost every risk-based engine, you'll see that. We really feel that once trust is established, trust is good. You should always verify it. but then you can continue to have trust. You can continue to extend trust. So if you are very confident, very high, and you can actually see here, I'm very confident, I know through these risk indicators, we'll talk about these kind of a little more in depth, especially Wi-Fi fingerprint, because I know y'all are excited about that. The outcome could be that you're remembered and you're extended. You don't have to auth again. Or if we're like a little unsure, let's go ahead and present a passwordless authentication. That's kind of low friction, or a duo push, which is also relatively low friction. Then if we're really in the gray area, or the orange area, I guess, you'll get a thing called verified push, which is also new technology I'll be talking through today, which is it's just coming up. And then finally, if it's really low, we're really certain it's bad, are going to just outright block that authentication.
I want to make sure I understand the chain that a session's going through. So this user logging in, are they hitting some kind of hardware gateway? Is it a cloud service? And what elements are in there besides Duo?
Yeah, it depends on really what they're protecting. So in our example, the single sign-on, what we're using there is a reverse proxy, basically, ultimately. And that is, we have two flavors of that here at Cisco. We have the Duo Network Gateway that lives on premises, and then we have now two managed solutions where we leverage fully cloud-hosted technology, right? So there's nothing on the customer's environment to do that work. We just take the traffic, send it to the Cisco cloud, and then back to the customer's premises. That's for those types of particular applications. But you absolutely could have the same thing on, let's say, bring your own identity provider, whatever. And the identity provider, if it integrates Duo, you'll get that same technology because you'll get primary authentication for the upfront vendor. Now, you might not get passwordless auth from them. You might, depending on what they support, but you will get the risk engine after that as Duo comes in as a second factor and does that work. So that's still consistent across all those types of technology.
Okay, but so there is Duo's functioning as a reverse proxy and intermediary, whether it's on-prem or...
Yeah, if it's a on-prem app, yep.
Okay.
So Wi-Fi fingerprint, we decided that this technology was needed because the IP, basically the collection of IP addresses and looking at that technology and even historics doesn't always make sense. Because let's say I'm a user, I'm coming in, I log in with I'm at whatever location and I do things like get on the VPN. Well, probably the way the routing works is I'm probably going to change IP addresses, right, through a VPN. And that could easily throw a false positive signal. So we use it because it is certainly a good indicator of basically location. But there's two things that does. It basically tells the system that you're logging into where you're at. So that system, it lowers your level of privacy because it can actually track you based upon your IP address. And that system could also keep a catalog of your IP addresses and where you've been historically. So as we see, security controls, we kind of jammed those in there during the pandemic, and we said, hey, we need all this work from home and remote work stuff, and we just jammed all the security controls in to protect it, but we weren't really thinking about user privacy, especially as we were developing those controls across that time frame. So this is kind of the opposite of that, and what we found was the SSIDs that your machines see is a very good indicator of where you are. So when you're at home, very likely to see the same or very similar or just at least a few slightly different SSIDs. When you go to the same coffee shop, same kind of thing. And we can actually use that in combination with the risk engine. Now it's not used alone by itself. There are other indicators, so like I showed, IP address, historical auth, GeoIP, those types of things are used within the risk engine. But we do leverage this, and it actually can work in places where IP address doesn't make sense to use, like when connecting to a VPN. So
Question.
yeah, please.
Sorry, is there some baselining there? So after a while, that unfamiliar location keeps happening, it'll eventually lower the risk?
Yeah, absolutely. Yeah, there's always baselining, and in fact, the whole risk-based engine does have to baseline through a period of time, but it's not long. We're talking about a couple weeks to really learn on behavior. We've seen things 60, 90 days. It doesn't take that long.
Does it report any kind of confidence score in its determination?
It does, yeah, and I'll actually show you all that. I'll take you through a demo to see kind of the back end of that.
Question real quick on that. The biggest concern, this is what Google was hit with a class action lawsuit for. This is what Marriott was hit for. This is what all these other organizations have been hit for, is collecting SSID data without informing people, not the user, but people around that they were collecting that data.
Yeah.
Huge class action lawsuits. I saw that the word anonymized was bolded.
Yeah.
The slide, which is great. But what are you doing differently to make sure that you're not putting the people who are using this in a position for a liable lawsuit, or putting yourself or Cisco in a position for a lawsuit for collecting this information?
Yeah, that's a great question. And you know, the design around the anonymized data is the first step to that, certainly. We will definitely look at things as we go through preview and take our customers through this that raise those types of concerns. You know, if we need to do flagging or ultimately messaging, or maybe even something within like DUO Health app or whatever that's collecting that data, perhaps a prompt, like we will be doing that throughout the testing period. It's still pretty early days on this, but yeah, that's
It's a great concept. I mean,
Yeah.
I mean, I see the value in it. I'm just concerned that everybody who's done something similar to this has been dinged for it.
Yes,
Service got nailed
absolutely.
for it. I mean, everybody's got nailed for doing this before.
Yep.
What makes it different from the way that you all are doing it? I understand conceptually it's really cool, and it's not, you're not doing it yet, right?
Right.
I mean, you're probably doing it at lab somewhere.
Yeah, exactly. Yep.
But that being said,
Yeah.
man, that's like, whoa, hold on.
Yeah, absolutely. Yeah, I mean, privacy is paramount with DUO security. Always has been. Actually, Ash Devada, who used to run does run our business unit, he, you know, put a block out that just said, you know, look, these are the pillars that we're worried about with this stuff. Privacy is most certainly one of them. So that is paramount. So still work in progress to get all that stuff figured out, but definitely top of mind.
It's very interesting concept about identifying location using things you don't normally think of.
So with that, are you really just using SSIDs? So, you know, Starbucks, if I'm in a coffee shop, it doesn't matter which Starbucks I'm in, it's going to be the same SSID.
Right.
So is there, if you're just looking at SSID, how do you?
Well, I mean, like there's BSSID, you know, like underneath the hood to that, right? So the DUO Health app is actually just talking to your Wi-Fi system, and those are statistics that can be pulled out of that, right? I'm not sure exactly how that crunches within the machine learning algorithm, how they use BSSID and MAC address and all that stuff. It could very well be used at this stage right now. It's just basically collecting SSID and crunching on that. Yep. But yeah, I don't know beyond the black box quite yet exactly what they're going to ultimately go to production with, but it is a consideration.
So they're not just checking the SSID you're on, but everything surrounding you that's detectable.
Yeah, exactly. We're looking, in fact, at the Wi-Fi list of networks, and we're just saying, you know, how does this look? And historically, how did it compare to what we saw before? And then basically saying, and I think, you know, I can give you like a rough statistic. It was something like, if we see 20% of the same networks, you're probably in the same location. There's like a 90-some% accuracy that you are. And that was done by our data science team to figure that stuff out.
So what you're saying is you can track me everywhere I go.
Uh,
You see what I'm saying? Like this is a real interesting thing. And I love it. I'm not trying to like pee in the Wheaties. It's just like,
yeah, no, absolutely. Absolutely.
no good.
Be in the Wheaties of Texas.
So basically, you know, for the tracking, what this does is it basically creates a hash of all these Wi-Fi networks, and that we never see this list. Like, never could we ever look at this list. All we can do is
I agree that you're gonna hash it, encrypt
Yeah.
it, but that's not the problem. The problem is that you're still doing it.
It's perception.
yeah, it's understandable.
Yeah. So if I'm in Starbucks downtown Seattle versus Starbucks in Chicago, other than the Starbucks Wi-Fi, I'm going to see a completely different pattern. Okay, that makes sense.
So as long as you go to a Starbucks that's near a McDonald's, you're good to go.
20%.
Look, you look at the so that's how we get away from their tracking you. You just have to have enough similar Wi-Fi networks that are available.
Right. That's it.
Yeah, you can tell the anarchists here. It's like,
Well,
we must stay under the radar.
Remember, it wasn't that long ago that every Starbucks in the country had ATT Wi-Fi as their SSID, so that all iPhones automatically hopped on it. So, I mean,
well, from a security perspective, also, if you're trying to break into your system, all you gotta do is figure out what Wi-Fi networks are next to you, throw open a Wi-Fi pineapple.
Or driving has a whole new meaning now.
30 seconds.
What networks are near this person's house?
These, and I've rebroadcasted them using a pineapple. Like, that's very easy to thwart.
Yeah.
Well, but
Like, it's cool.
Which is why you can't. You can't use that single alone.
Yeah, you can't. I get it.
doesn't
It's
work.
one.
Yeah.
It's
well,
one,
but
like,
that's also why they're looking at the BSSID, not just the SSID.
yeah,
Right.
but I mean, you can fix
So
it
you carry a
Well,
little
yeah, but-
access point that advertises the 4 SSIDs that are in the place you want them to look like they are.
all the time.
Or You just have the same
like-
four
No, this is
always
great.
on. That way, no matter where you are,
Exactly what we
There
are.
you are,
Right,
exactly.
Kind of stuff.
But I agree that it is one, it could be one key thing in the continuous authentication mechanism. It could be, but like, that's just kind of scary to me.
So
You integrate any of that data with like wiggle.net or
Yeah,
anything like that
right.
to validate locations?
yeah, so everybody has location validation and the IP address data. We're not doing, so there were some test subjects around that and there's some data around it, but ultimately I don't know what we're going to do in production. Unfortunately, I'm not in that level yet of it, but yeah, it could be. But ultimately right now, like we use a system of like IP address and then we process that across the same IP address database that everybody else does, right? Like, so it's like around that idea, but I don't know the depth of what they're going to do with that data and how they're going to process that yet for accuracy and all that stuff. So
into the same topic, but the flip side of it.
Yeah.
If this is something that you enable from a kind of an admin standpoint, am I able to go in and see how often that's coming up as success versus failure? And can I, from home, this is what I see. Can I get to that level of, I can see how effective it is in my org or in, if I go from a conference room inside of my corporate building to another one, well, there's different business, can I get into the kind of the logs to see how successful it is?
I'll actually show you some of what the logs look like. The answer to your direct question right now is not yet. And I assure you we will move that way because that's the exact questions we're going to get asked. Like risk-based authentication is like a box you just shove stuff in, a machine learning algorithm spits stuff out. And yeah, human beings want to know, like, what'd you do? How'd you make that decision, right? So yeah, absolutely. So I want to talk about the authentication flow a little bit, just high level. End user comes in, the trusted signals go, they crunch the numbers on the data that we're feeding it about the authentication, and then there's a risk score at that point in time. And now we can do additional things based upon that risk score, like step up, step down, those types of things, introduce strong factors. But ultimately, we'll introduce that if the user passes, they get in. But on the converse of that, if it's a high trust scenario where the signals are similar to or almost exact to what we saw before, then we'll expedite. So a very simple concept. I'll actually show you now a little bit of this in process. So I'll warn you, demonstrating Wi-Fi networks, like being the same and not the same, is really boring and not really very showable. But what I did do was I showed you, I'm going to show the concept of kind of like a known auth versus an unknown auth versus that kind of thing. So initially when I do an authentication, like nobody knows who I am. So I do need to do some kind of verification step. So this is, post login, going to a company directory in this particular use case. And then I'm going to go through a process of authentication. So this is cert collection for trust. And then it moves into multi-factor authentication. So I'm going to do that auth here, and you're going to see that. Now I'm untrusted at this point, right? It says, I'm placing you into MFA because I have no idea who you are. Now I'm going to auth you, and then I'll show you a little bit of kind of the jot token behind the scenes or the actual data that is getting spit out of the engine. So the prompt's collecting your IP address. You're actually going in. This is, again, utilizing the network gateway because that's an on-prem thing. Health and hygiene is happening. But then we have some data behind this now. So now we know we collected all the things because the health agent's going to collect your device health, and then you get access to the application. Behind the scenes, we collect a particular amount of reporting data in there to put that into the engine to crunch that. So we're taking a look at that here. And the one in particular I want you to know is IP address, because that is within the engine's capabilities to take a look at that for location. But now we trust this user because they did MFA. So we understand who they are, we trust them. Now I go connect to the VPN. Just ignore the VPN auth because this part isn't really what we're showing here. It's just connecting us just so we can change our IP here. And when we do that, now that we're connected, we're gonna change IPs because now we're coming out through the corporation because that's the way we're getting routed. And then if you look down here, like we say, okay, yes, that's the end user's IP, but the Wi-Fi signal's kicked in now. And it said, oh, this is the same user with a high degree of trust. We know that based upon the SSID collection, that this person's probably the same. So notice it didn't say untrusted, it said trusted. So now this person goes to log into that corporate directory again, and we kick in that risk-based engine and say, okay, the admin did select a policy that says if there's a high level of trust, you can expedite the user. And because they do, now we don't stop them here with the friction. We actually still collect the device telemetry, but we log them right in.
Are you going to talk about any of the like application monitoring, you know, or the risk assessment based on what it is that they're trying to do, you know, resources that they're trying to access? Because
Yeah.
that's kind of one of the concerns. It's like, or not the concerns, but the way to find those anomalies is, you know, let's say I've got your cell phone and I go through this and I've chopped your finger off. I've got your finger and I can hit your key. I can go through multi-factor there. But then I want to download, I mean, the example yesterday was like 600,000, you know, Salesforce documents or whatever.
Yep.
At what point does that come along in this process?
Yeah, so that's, I'd say, next phase for us.
Yep.
And the idea behind that is third-party intelligence feeds. And that third party could be Cisco still, right? But it just says the risk-based engine will sit there and it will wait for a feed to say, like, I've got a technology that looks at that, looks at common behavior, DLP type solutions, whatever those are, and it would say, hey, anomalous activity, feed that into the risk engine would enforce those controls at this point in time. We do something similar today already with secure endpoint. And secure endpoint, if secure endpoint finds malware and quarantines that device, the APIs will talk back to DUO and DUO will block that outright. Yeah. It's that same idea, which is be the next evolution of that, which is exactly like next phase of risk-based auth. After you put it out with the risk indicators with the Wi-Fi stuff, next piece is third-party threat feeds.
And then and I'm still worried about the three kids, you know, standing on top of each other's shoulders with the overcoat, walking to the front door. Once you're in, you're in. Like, I mean, everything you've shown so far is great, but like once you're in,
absolutely
party time.
Yep.
You know.
So let me spin through this one real quick because this one isn't super flashy, but it's just something. It's a little bit of a catch-up feature, but how we're doing it is different. So if you're familiar with Microsoft MFA, you can turn on a setting that says do verified push authentication, which means you'll get a code on your screen. On the actual screen, you'll get a code. On the device, you'll get like 3 codes, and you have to select it to get in. That's basically saying you must be in front of this thing, and it can't be just some random Joe accepting pushes on your behalf, right? So it helps with the push phishing issue, and there's a number of issues with that. This just demonstrates kind of like what it looks like here. If you get put into a mode where you need to verified push, which would be a low trust mode, we'll kick you into this. So I have a demo of this, but honestly, with the time, I do want to get to kind of some of the continuous trusted access stuff. Ultimately, what that demo ended up showing was it showed 3 authentications, and it showed the admin side of the house. The admin logs, I'll throw it up here just so we can see it. The admin logs would track each one of those authentications. So if you're in you know, the DUO admin side of the house and you're watching a user authenticate, you're going to see things like this. So this is a bad actor. They actually compromise credentials. They're like, push, 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 right? And we see that pretty commonly. And the risk-based engine's like, whoa, this is like 3, 4 pushes like right in a row. That's not right. And so it steps up that to the verified push. So now the bad actor can't just go to the screen and hit the push button trying to get the user to do that. They actually have to take the code out of the app, which they don't have the app, because they don't have that device, and they have to punch in that 6-digit code. So the difference between our implementation of this and Microsoft implementation of this is Microsoft just turns it on. You have to have friction every single time you authenticate. You have to choose that. We only introduce the friction when it's necessary. There's other use cases too, like if I got a push notification and it wasn't me, and this has happened to me once or twice, like it's terrifying because it's like I go like, who compromised my credentials? Because the only way I can get this push is if somebody stole my username and password. But that's what multi-factor's for. So you know, you get a push, you mark it as fraudulent, and that actually DUO already sends a email to the administrators to let someone know that there's been a fraudulent authentication attempt. But then we would then step up to that verified push for every attempt after that. So the bad actor, like, they can't send that push again. They're locked out. Continuous trusted access is built on a piece of technology we call session trust analysis. So basically what we have done is we're actually members of the OpenID Foundation. We help develop these standards, CAPE and RISC. They're 2 standards that do what are called shared signals. So shared signals are basically a way for somebody like a security vendor to talk to somebody like a SaaS vendor. So in this particular case, our SaaS vendor is Box. And this is an example of exactly what was described, which is post authentication. Now I'm in the door. I've done my biometric authentication. What happens when I start messing around? Or what happens if my identity changes or like anything like that? And the idea behind this is we do all the technologies that we mentioned up front so far. So you're going to see going through doing a dual push, all that good stuff. And then you're going to access your system within Box. So again, I like to kind of poke at Lee a little bit here. Lee is our user that likes to turn the firewall off. So we're going to use that example again. But you can imagine this being any kind of stuff. Like, and this would be where like we could feed into behavioral engines, but we create the building blocks of this, and we actually we really improve the logging around this. So now you get actually user events log, and you get to pretty much see within Duo like how is that user behaving. Now it's only through things like purposeful actions. Like, so we're not tracking like the mouse moving across the screen all the time. Like, that'd be terrifying if we had got tracked to that level. But we do track things like security eventing stuff. So somebody like the endpoint detected something mid-session. Now, mind you, I'm not logging back in. So this is literally Lee went and turned the firewall off before we saw the procedure of next time I access my application, I'm actually going to get, you know, blocked there. But this is Duo Health app has detected this, and a shared signal event now goes right into Duo. So as soon as Lee turned that firewall all off, we now see that. So now we've said, okay, Lee, you better cut that stuff out, and we revoked your session. And then we share that signal across any of the providers that work with the shared signals ecosystem, and we say revoke their session. So now Lee is back on box.com. We'll see, navigate back over to that, just, you know, a little bit more logging here, basically telling it what to do. Clicks on the folders, out. Completely dumped out, can't do anything now. Now, again, we can log them back through. Like, we can take them back through the engine. We could say, hey, Lee, go turn your firewall back on and be a good citizen, and we'll let you back in. But until then, you're blocked out. So that's the idea. This is the start of it, right? Now, again, third-party threat feeds, working with our partners, getting different signals for different actions is the idea going forward. This is just basically how we start. We created that framework. Now it's about getting the framework to be adopted and used by our partners, and then ultimately collecting additional telemetry from third-party threat feeds and other things to work into this engine.
At what stage do you take something like this and instead of just working at the application level or the operating system level, move it down in integration with SASE for home office users where you can't even get on the network? You can't even authenticate to the wireless access point, much less the VPN or anything else.
I mean, we're already talking about that, right? How does the Cisco ecosystem work with all this stuff? Feeding it into a central repository, central policy, and all that stuff, right? So.